Welcome back to the deep dive. If you work with large language models, you definitely know the alignment process. Things like RLHF, DPO is just non-negotiable for safety.
Right.
But you also know the price we pay, the persistent and frankly frustrating issue of mode collapse.
That's a perfect way to put it. It's the technical debt of alignment. While these methods are great for steering models toward useful behavior, they often just unintentionally prune the model's huge generative space.
And that really limits their use.
Oh, absolutely. It limits them in any creative or stochastic task where you actually want variability. Think creative writing, realistic social simulation, or even generating diverse synthetic data.
So our source paper today offers a perspective that, well, it pretty much reframes this whole problem. It argues that mode collapse isn't just some algorithmic side effect.
No, it's a symptom of a fundamental bias that's embedded deep within the human preference data itself.
A data-level problem.
Exactly. For you, our expert listeners, the core contribution here is a real paradigm shift. We're talking about, first, a new theoretical framework that identifies something called typicality bias as this pervasive data-level cause.
And second.
The introduction of verbalized sampling, or VS. It's a principled, training-free remedy you can use at inference time. So our mission today is to walk through the heavy empirical validation that shows VS, well, it doesn't just theorize a fix, it delivers huge gains in the real world.
Okay, let's unpack this then, diving straight into the theory. This paper is making a pretty novel claim that we need to stop thinking about mode collapse as, just a failure of KL regularization.
Or a bad reward function.
Right. And start looking at the psychology of the human annotator.
They formalize what they call typicality bias. And simply put, it's just the tendency for human annotators when they're faced with two equally correct or valid responses to systematically favor the one that feels more familiar, the one that's fluent, predictable.
The one that aligns with the base model's kind of default common sense output.
Exactly. And this preference is deeply human. It comes from cognitive principles we all know well, the mere exposure effect, the availability heuristic, just general processing fluency. If a response is easy to read and fits expectations, it gets a higher reward. Simple as that.
So the preference learning framework, which is really the engine of alignment, it essentially learns to prioritize this familiarity signal. How do they actually model this mathematically?
They augmented the standard reward function, VUA, which is what captures human preferences. They propose it's made of two parts, the true task utility and this new bias term.
And for the bias term, they needed a proxy.
Right. A tractable, measurable proxy. And they use the base model log likelihood, log Peyersfall for that. It's a great proxy for text typicality.
So the equation is basically structured to pull apart the true utility from what's essentially just a familiarity bonus.
Precisely. The formalization is war x, y, x, y plus alpha log higher of x plus epsilon. The critical parameter here is that alpha, the typicality bias weight. If alpha is greater than 0, it means a human is giving a non-zero reward just for typicality, completely separate from whether the response is actually good for the task.
That is a very strong theoretical claim. Did they manage to verify that alpha is actually positive?
Yeah.
Across real preference data?
They absolutely did. They used a rigorous statistical analysis on the help steer data set, and they were meticulous, they controlled for correctness, isolated pairs where raters confirmed similar utility, but one response was clearly more typical.
And the result?
By fitting the Bradley-Terry model, they derived a positive typicality bias weight that was consistently between 0.57 and 0.65.
And that held across different base models?
Yes, across various base models used as the reference distribution. And this was highly significant p-values far below $10–14. It's pretty definitive evidence that human raters favor base model typicality independent of true task utility.
That is a powerful finding. Okay, so let's trace this positive alpha through the RLHF optimization. What does this mathematically mean for the aligned model's final distribution?
It leads directly to the mechanism of distribution sharpening. When you plug that bias reward function back into the PEL, the closed-form solution of the KL regularized objective, which is the standard RLHF or DPO solution, the resulting optimal policy is strictly sharpened by an exponent, gamma.
And the relationship is gamma equals 1 plus alpha over beta.
That's the one, gamma. 1 plus alpha beta, where beta is just the standard KL coefficient.
And crucially, since we know alpha is positive, and beta has to be positive for regularization, gamma must be strictly greater than 1.
Correct. So the final distribution is proportional to the pre-training distribution, raised to the power of gamma.
So it's like baking a low-temperature setting directly into the model's DNA.
That's a great analogy. This power transform, it acts exactly like temperature scaling, but it's permanently baked into the aligned model. The probability mass is just. It's inevitably compressed toward the modes that were already favored by the base model.
It's a mechanism that just forces the diversity out of the system.
It is. Consider an open-ended scenario like generating a poem. You might have many responses with the same true utility arc true, but this typicality bias acts as a strict tiebreaker. It compresses the probability toward the single most familiar, most fluent response.
And the result is mode collapse, a mathematically narrowed solution space.
Focused on the familiar.
Which means the challenge isn't that the model forgot how to be diverse, it's that the alignment process literally told it not to. Okay, let's pivot to the solution. Verbalized sampling, or VS. It's described as a simple prompting strategy.
Right, designed to recover that inherent diversity that was always there in the original pre-trained model, in Fear.
The central insight seems to be about prompting structure.
Yes, it's realizing that different kinds of requests make the model use different sampling modes. An instance-level prompt, tell me a joke, collapses to the single most typical mode.
And a list-level prompt, like give me 5 jokes.
That often leads to this unnatural, artificially uniform distribution over those 5 items. Not very realistic.
But VS uses a distribution-level prompt. Why is that distinction so crucial? Why does asking the model to verbalize probabilities suddenly change its behavior so much?
It forces the model into what you could call a metacognitive state. When you explicitly ask it to verbalize the distribution itself, say, generate 5 diverse responses with their corresponding probabilities, you shift the mode of its response. It starts to approximate the underlying statistical distribution it learned during pre-training before that gamma sharpening took effect.
So it's leveraging the model's linguistic ability to express uncertainty.
Exactly. It's a way to circumvent the typicality bias that's applied during normal greedy or top sampling.
But wait, for our listeners, isn't there a risk here? A risk that by asking the model to verbalize probabilities, we're just getting it to hallucinate a distribution, not actually recovering the true suppressed pyre.
That's a crucial critical point, and the paper addresses it. They measure the accuracy of the verbalized distributions against empirical frequencies and find a high correlation. So the claim isn't that the model is perfectly introspective.
It's that the prompt acts as a kind of regularizer.
A strong regularizer, yes. It guides the generation process away from that narrow mode and back toward the boundary of its pre-training distribution. You're asking it to perform a complex statistical task, which naturally requires it to engage that full statistical range it was trained on.
And the implementation is just. It's remarkably simple. That has to be a major selling point.
Oh, huge. It's training-free, model-agnostic, and importantly, it requires no logit access. You can use this with any black box API app.
Just a type structure.
An elegant one. System and user prompts ask for a set of responses. The text is clearly bracketed in response tags, and each one is paired with a numeric probability tag. Super easy to parse.
And they mention variance, too.
They do. VS-CoT, which incorporates chain of thought for more rigorous reasoning, and VS-Multi, using multi-turn mechanics. These were shown to be particularly good for getting more diversity out of the larger, more capable models.
Here's where it gets really interesting for me. The empirical results. They test this across 4 major categories, showing how this simple prompt, it just systematically retunes that critical diversity-quality trade-off.
Yes.
Let's start with creative writing. That's always been the poster child for mode collapse.
For sure. On tasks like generating poems, stories, jokes using established datasets via standard achieved, well, the results were dramatic.
How dramatic?
When you quantify diversity with semantic metrics, VS consistently increased output diversity by 1.6 to 2.1 times over standard direct prompting.
Wow. That's not a marginal gain?
No, it's not marginal at all. This is recovering a substantial amount of creative bandwidth.
But is this at the expense of quality? Because usually, you crank up the temperature, you get diversity, but you also get garbage.
And that's the power of the mechanism. VS Standard maintains quality, but the variants, especially VS-CoT, they actually approach the Pareto front, that sweet spot. They got the highest diversity while simultaneously maintaining a high-quality score, judged by models like Claude 3.7 Sonnet.
So the quality control is almost inherent to the method.
It seems to be, because you're recovering the base model's valid statistical range, not just injecting random noise.
And the ablation study using the Tulu-3 family, that really tells the whole story.
It's the smoking gun evidence. After the DPO alignment stage, you can see direct prompting retains only 23.8% of the base model's original diversity. The mode has collapsed, just like the theory predicts.
And with VS.
In stark contrast, VS retains a remarkable 66.8% of that inherent diversity.
That's nearly a threefold improvement.
It is, just by changing the inference time prompt. It's shocking.
That magnitude of difference. It implies the creativity was always there. We just needed a specific linguistic key to unlock it.
There's an important scaling trend here, too. The diversity gains are nonlinear.
Meaning bigger models benefit more?
Way more. Larger, more capable models like GPT 4.1 and Gemini 2.5 Pro show 1.5 to 2 times greater diversity gains from VS than the smaller models do.
Which confirms VS is tapping into latent knowledge in those massive models.
It does, and practically speaking, VS gives you something else. Fine-grained diversity tuning. You can adjust the probability threshold in the prompt. That's a level of control that traditional decoding methods just don't offer.
Okay, let's move beyond creative tasks. Let's look at distribution recovery and structured open-ended QA. This is so critical for things like social simulation, where you need all the possible answers, not just the most common one.
Absolutely. Think about enumerative tasks like name a U.S. state.
Yep.
Direct prompting always collapses to California and New York, Texas.
The usual suspects.
Right. So the metric here is KL divergence, comparing the model's generated answer distribution against a realistic reference from a huge corpus like red pajama. We're asking, how well does the generated distribution match human reality?
And the answer.
VS Standard significantly lowers that KL divergence, and it dramatically improves coverage N, which is just the fraction of unique ground truth answers you generate. VS Multi was the best overall.
How close did it get?
The distribution they got from Claude 4 Sonnet using VS aligned incredibly closely with the reference. It achieved a KL divergence of just 0.12. And critically, this is all while maintaining high precision. The answers are diverse, but they're still correct.
This really moves VS from being just a novelty tool for creativity to an essential calibration tool for stochastic simulation. How does this play out in concrete downstream utility? Dialogue simulation, for instance.
Dialogue simulation is hugely sensitive to this. In the Persuasion for Good task, direct prompting gave these generic, predictable resistance responses. But when they applied VS to simulate the persuadee...
The AI people in the simulation.
Right. The resulting donation distributions were far more aligned with observed human behavior. Lower KS tests, lower L1 distances.
So the AI people behaved more like actual humans, showing realistic unpredictability.
That's exactly it. In fact, GPT 4.1 with VS matched the performance of a dedicated, fine-tuned Llama 3.1 8B simulator. And DeepSeek R1 actually surpassed it. It enables modeling complex behaviors like a realistic change of mind that typicality bias usually suppresses.
And finally, synthetic data generation. This is a major scaling bottleneck for everyone right now. How did this diversity translate to better training data?
The paper confirms that VS-generated data is inherently more diverse and more challenging, and that directly improved downstream model performance when they used it for fine-tuning. They focused on competition math, generating synthetic questions.
And using them to fine-tune models like Qwen.
Yes, Quenon 2.57b and Qwen 3.4bs.
And did the fine-tuned model see a real performance bump?
Substantial one. Models trained on the VS-generated material showed improved accuracy across hard benchmarks like Math 500 and Olympiad Bench. The VS multivariant got the strongest average accuracy, 37.5% compared to 32.8% for the baseline.
That's a pretty significant utility boost.
It is. It shows that the diversity injected by VS makes the synthetic data a much richer training resource. And they also showed it improves the generation of diverse, challenging, incorrect negative examples, which is crucial for modern offline RL training.
So to bring this all together, we've established the problem of mode collapse is fundamentally rooted in this cognitive typicality bias in our preference data, which mathematically sharpens the pre-training distribution with that gamma exponent.
And that verbalized sampling is a practical, principled, and highly effective inference-time solution. By using a distribution-level prompt, VS recovers the inherent generative diversity of the pre-trained model.
And this effect is strongest in our biggest, most capable models.
Right, and it yields substantial quantitative gains across high-value applications that need realistic variability, like social simulation or synthetic data creation.
This really changes how we have to think about that trade-off. We don't have to just accept that an aligned model must be a bland model. The diversity is still there.
It's still resident, yes. It's just veiled by a heavy, learned bias that VS provides the key to peel back.
Which is an incredible insight.
Precisely. And that leads me to a provocative final thought for you to consider. Since VS effectively recovers the full pre-training distribution and dramatically enhances the diversity of outputs, think about the implications for advanced online reinforcement learning.
RL.
RL requires vast exploration of the action space to find optimal policies. Leveraging VS to generate a much richer, more diverse set of candidate actions could fundamentally improve the exploration and effectiveness of advanced online RL. It suggests a promising new paradigm for training truly capable, robust, and diverse models in the future.
If you want to dive deeper into the formal definitions of typicality bias, explore the mechanics of that gamma exponent, or just review the exhaustive empirical results, you should check out the source paper by Zhang et al. The number is the 2052.01171. This is a crucial read for anyone serious about the future of diverse LLM applications.